Rahim. Assalamu alaikum dear students. This is our next problem. Problem as usual, having been selected or chosen from the book Modern Physics by Kenneth S. Crane. As usual, we first come to its statement. The vibrational transition in beryllium oxide. Okay, dear students, this is not barium oxide. If it is BeO, then it will be pronounced as barium oxide. It is not barium oxide, it is beryllium oxide. The vibrational transition in beryllium oxide is observed at a wavelength of 6.724 micrometer. Micro stands for 10 to power minus 6. It is the converse of mega or million. Okay, dear students, because when we move towards the positive side of 10 raised to the power, then its arrangement is from kilo, mega, giga, etc. But when we move towards the negative side of 10 raised to the power minus 3, minus 6, minus 9, minus 12, etc., then we call milli, micro, nano. Okay, kilo, million, giga, while milli, micro and nano. Okay, at a wavelength of 6.724 micrometer. What is the effective force constant of beryllium oxide? What is the effective force constant of beryllium oxide? Now, as usual, we move first to helping tools, and then after helping tools we will come to solution of the problem in a formal manner. Okay, helping tools. Tool number 1. In this tool, reduced mass of a diatomic molecule is defined or expressed in mathematical form. Okay, reduced mass of a diatomic molecule Mr, where R is written as a subscript of M, okay, is equal to multiplication of those two, that is mass of atom number 1 and mass of atom number 2, that is M1 M2, multiplication of both atoms, atom number 1 and atom number 2, over M1 plus M2, that is addition of atom number 1 and atom number 2. Okay, quite simple, no rocket science. Okay, reduced mass of a diatomic molecule, that is Mr, where R is written as a subscript of M. So Mr will stand for reduced mass, small r stands for reduced, and small m stands for mass. Okay, reduced mass of a diatomic molecule Mr is equal to the product of those two atoms in the numerator and addition of those two atoms in the denominator. Okay, reduced mass of a diatomic molecule Mr is equal to M1 into M2 divided by M1 plus M2. Okay, now we move to table number 2. Okay, dear students, in this table a few snapshots have been selected from one book or perhaps more books. Okay, from this table we will not only take a value, but a sense of confidence will also develop regarding solution of such problems. Okay, so dear students, first first snapshot is not of our use. Okay, it deals with a alphabet. Okay, actinium, aluminum, americium, antimony. Okay, the main thing which needs to be displayed in this first part of tool number 2 is that in the first column element name is given, in the second column symbol of that element is given, in the third column atomic number Z of that element is given, and in the fourth column molar mass, that is gram per mole, is given. Dear students, this table is quite lengthy. Okay, but here I have selected only first 4 columns. Okay, because we are concerned only we are concerned only with such expansion of this table. Okay, otherwise if we consult this table from the book, then we will see that this table comprises several pages in length and also in width. Its number of columns are at least double than these. Okay, so anyhow, yes students, part A, this is part A, aluminium, actinium, aluminium, americium, antimony. Okay, part A. Second part deals with B category of elements which begin with alphabet B. Okay, barium, Ba. But our ionic molecule is not barium oxide. It is in row number 3rd, beryllium, Be, is given. Okay, beryllium, Be, atomic number Z4, and molar mass gas per mole becomes equal to 9.0122. Okay, we will use this value. Okay, and this value is in U, atomic mass unit. Okay, in the next table we will see how atomic mass unit U can be converted into other form. Okay, now okay, in first part of tool number 2 we were not concerned with any element given in a category beginning from alphabet A, while in the second part of this table, which deals with elements beginning from B, the only one element, that is beryllium, Be, is of our use, while first row barium, Barium, which whose symbol is Ba, is presently not in our use. Okay, we are concerned with the third row, beryllium, Be, 9.0122. Okay, now we move forward. Okay, and see third part of this table. Okay, third part of this table deals with element, third snapshot of this table deals with those elements which begin from the alphabet O and P. Okay, osmium, oxygen, palladium, phosphorus, platinum. Okay, here oxygen O, 8, 15.9994. Okay, this is our relevant row. Okay, oxygen, symbol capital O, atomic number Z 8, and this is gram per mole, that is atomic mass unit U. Okay, 15.9994. Okay, so from this table we are concerned with two values. Okay, beryllium Be4 9.0122 and oxygen 8 08 15.9994. Okay. Dear students, table number 3 has been used several times in our previous problems, previous videos. Okay. Here, value of speed of light c, which is equal to 2.998 into 10 raised to the power 8 meter per second, will also be used. Okay. Moreover, yes, 1 U is equal to 931.5 million electron volt over C square. This value will also be used. Okay. 1 U, 1 atomic mass unit, is equal to 931.5 million electron volt over C square. Okay. This will also be used. Now we move to solution in a formal manner. Okay. Solution of this problem. Let us first calculate the reduced mass of beryllium oxide as Mr, where R is written as a subscript of M. Okay. Mr standing for reduced mass is equal to, in the numerator, multiplication of both atoms, and in the denominator, addition of both atoms. Okay. So Mr is equal to M1 into M2 divided by M1 plus M2. Okay. Dear students, these two values are those which we have shown in our table of elements. Okay. This is atomic mass unit of beryllium, and this is of oxygen. Okay. But this ionic molecule will not be called beryllium oxygen. It will be called beryllium oxide. Okay. These things are basically of chemical nature, and in chemistry students deal with such minutes in a relatively more comprehensive manner. Okay. However, we will also deal with such things to the extent they appear in our study material. Okay. So Mr is equal to atomic mass unit of beryllium into atomic mass unit of oxygen divided by atomic mass unit of beryllium plus atomic mass unit of oxygen. Okay. And hence after simplification it becomes equal to 5.76 U. 5.76 U. Okay. This is the reduced mass. Now we move forward. Okay. We know that frequency and wavelength are related by the expression small f is equal to c over lambda. That is, frequency and wavelength are inversely proportional to each other, and this inverse proportionality is converted or transformed in equality by using a constant, which constant is speed of light c. That is 2.998 into 10 raised to the power 8 meter per second, and we usually take this value as 3.00 into 10 raised to the power 8 meter per second. F, frequency f is equal to c over lambda. Value of c is knows everyone almost. Okay. And the table which we have introduced in this problem, value of c is also given in that table. Okay. Divided by wavelength lambda, it is given in the problem statement. Okay. So we have chosen one value. No, yes, we have chosen one value from table, but this value is so basic, so fundamental, so famous that we should not give reference to table. Okay. We should have verbally remembered it. Okay. So frequency f is equal to speed of light c divided by wavelength lambda. and after simplification this becomes 44.6 into 10 raised to the power 12 hertz. Dear students, what is hertz? Hertz is second inverse. Okay, in place of hertz, per second can also be written, but hertz means cycle per second. Okay, so it is enough. We know that frequency is given in term of hertz, and 1 hertz is equal to one cycle per second. Okay, rather one cycle, not rather number of cycles per second. Okay, number of cycles per second. Okay, we now we move to remaining part of this problem. We know that vibrational frequency is given as vibrational frequency f is equal to 1 over 2 pi into under root k over m. We have to find the value of k. Okay, fourth constant k. Okay, frequency, vibrational frequency f is equal to 1 over 2 pi into sine of under root k over m. This alternatively becomes equal to 1 over 2 pi into, dear students, we have multiplied and divided by c square this expression within the sine of under root. Okay, what we have done, we have multiplied and divided it by c square within the sine of under root. Okay, or in other words, we can see that we have multiplied and divided it by c outside the sine of under root. Okay, so when f is equal to this, then this implies that if we square both sides, then we will have a frequency f square is equal to 1 over 4 pi square into kc square over mc square. Okay, but here, dear students, we have to find out the value of k. When we have to find out the value of k, then we will keep k on one side and transfer all other constants and variables on other side of equality, and our expression will take the form as k equal to frequency f square into 4 pi square into mc square divided by c square. Okay, dear students, in the next step, this thing is important to note. Here c square is cancelled with c square. Okay, but despite this, in the next square, c square is appearing in the denominator. Okay, this c square is not this c square. Okay, dear students, this is the almost first form of our required expression. Okay, in this equation or expression, c square is cancelled with c square. Okay, and we have values only in the numerator. Okay, so what we do, first we take the square of frequency f which we have calculated above. Okay, how many are this is 44.6. Okay, into 10 raised to the power 12 hertz. Okay, so here first value has been put, value of frequency s, vibrational frequency f. Okay, frequency square into 4 pi square, 4 into pi is equal to 3.14. This is actually 22 by 7, and we know that its decimal representation is non-terminating, non-repeating. It goes endlessly. Okay, this is a magic of mathematician. Even if this thing does not come in our mind in a very clear cut picture, we will have to adopt this result. We will have to acknowledge that value of pi, which is 22 by 7, is equal to 3.14 and other digits, and these other digits go endlessly. They do not repeat themselves, they do not terminate at any stage. Okay, so this thing is a little speciality in physics and mathematics. Okay, so here after 4 we have also put the value of pi square, then into m into c square. Okay, what is m? M is reduced mass. Okay, here we have just used the value of m because c square has been cancelled with c square, and reduced mass m is equal to this 5.76 u. So here 5.76, okay, 5.76 u. Here u does not appear because in place of u we have used this value, because let us once again go back in this table. This is 1 u is equal to 931.5 million electron volt over c square. Okay, so we have used this value. In place of u we have used this value, and this value contains c square in the denominator. So dear students, this c square this c square yes, this c square has been cancelled with c square, but this c square is that c square which is occurring in with this million electron volt over c square. Okay, we have shifted this, we have written this c square in this form. Okay, so nothing unusual, nothing ununderstandable. Okay, everything is quite clear and easy to understand. Okay, in the next step, what we have done, we have taken square of this value 44.6. okay, its square will become this. Okay, then 10 raised to the power 12, its square will be 10 raised to the power 24. Then hertz will also appear in square form, hertz square. Okay, okay, so this is the matter with the 44.6 into 10 raised to the power 12 hertz square. Okay, 44.6 square has taken this form 1989.16, and 10 raised to the power 12 after being squared has become equal to 10 raised to the power 24, and hertz after having been squared becomes hertz square into, what is this? We have multiplied 4 with the square of this. Okay, square of this will be greater than 9, that definitely, because this figure is 3.14, so its square will be more than 9. Okay, and when it will be multiplied with 4, our answer will be this. Okay, 39.44 into this figure into 39.44 into 53. Yes, yes, quite actually we have multiplied this 5.76 with 931.5. okay, quite simple, quite simple. Okay, because if we assume this 931 as approximately equal to 1000, then this result will become 5000 about. Okay, and its exact value is 5364.44 million electron volt. Okay, million electron volt over c square, over c square. Here in place of c square we have used its value, which is equal to 2.998 into 10 raised to the power 8 meter per second. And sometimes we do not write it as 2.998, we simply write 3 into 10 raised to the power 8 meter per second. So here in place of c square we will have to put this value. Okay, next simplification, nothing else. There is no need to explain these steps. These steps are of the nature of almost 7th class mathematics. Okay, 7 and 8th class. Okay, so dear students, next step has become equal to this, and then next step has become equal to this. How this step has become this? Because, dear students, actually we have made a change in this, that this figure is 4677024. Here we have reshaped or changed its pattern as 4677. Okay, point. We have shifted decimal to 3 stages back. That is why. No, rather we have shifted four stages back, 4 stages behind. Okay, because it is written 4677.0224 in place of these we will get 10 raised to the power 4, and this 4 will be added in this 14 and it will become 18. Okay, in the next step, dear students, we have again reshaped this value and we have shifted decimal 3 stages back, and hence this 10 raised to the power 15 has been further enhanced to 10 raised to the power 21. Okay, just okay, 4.677 into 10 raised to the power minus 21 electron volt over meter square. To this extent our solution is 100% correct and acceptable, but just as a fashion of physics we are going to adopt next step. What next step? Dear students, actually out of this 10 raised to the power 21, 10 raised to the power 18 will be equal to nano square. Okay, because out of this 10 raised to the power 21, 10 raised to the power 18, if written in the denominator, then it will be along with sign minus, that is 10 raised to the power minus 18, and we can write 10 raised to the power minus 18 as 10 raised to the power minus 9 into 10 raised to the power minus 9, and we know that 10 raised to the power minus 9 is equal to nano. So meter square is already present in the denominator, and from a numerator we will separate 10 raised to the power 18 from 10 raised to the power 21, and it will be shifted to denominator, and hence nanometer square will become. Okay, both these values are 100% equal and 100% correct, acceptable, but we have just reshaped this quantity, this value into this, because this was in meter and this is in shape of nanometer. Okay, 4.677 into 10 raised to the power 3 electron volt over nanometer square. And this is the end of our problem, end of our video. Till next video, Allah Hafiz.